Good evening, guys. Today we are going to discuss the hierarchical clustering. In hierarchical clustering, first of all, let us understand the term clustering. What do we mean by clustering? Clustering means grouping the data which are similar in nature together. This is termed as clustering. Okay. Now, we are going to discuss about the types of hierarchical clustering. There are two types of hierarchical clustering. The first one is the agglomerative and second one is the divisive. What happens in agglomerative? It is bottom to top approach. What happens is that suppose I have taken an example also. I have my so many data points in the data set P1, P2 to till P6. Okay. So initially what I think is that I will consider each of these point as a cluster, and then I will join or merge these cluster on the basis of their distances. Like just see here, this is my one cluster, this is my one cluster. I see that these two clusters were close, so I merge them and make them a big cluster. So this happens in agglomerative clustering. While what happens in divisive is that first we take a big cluster and then we divide it into subclusters. Okay, so you must be clear. Now the second thing is that agglomerative clustering is more important in the real life because it is more easy to merge two clusters than to decide that how many clusters we need to divide. Okay, yes. Now if I give you some practical real life example where we do clustering is that, for example, we are clustering student on the basis of their marks, or we are clustering customers on the basis of their shopping habits. Okay, let me give an example. In the agglomerative clustering, what I have told you is that suppose these were my initial clusters P1, P2. Now, what will happen is that I saw that P1 and P2 are close, so I made them a cluster. I saw that P4 and P5 are close, so I made them a cluster. And I checked that the P3 distance is more closer to this in comparison to this, so I clustered it here. And P6 distance is more closer to this cluster, so I clustered it here. Now what will happen is that now I will merge these two clusters also and I will get my final cluster. Okay, so you must be clear what happens behind this. I will be telling you how we measure the distances and all these things, but first of all you should have this basic idea. Now in this agglomerative clustering we have a visual representation. It is called a dendrogram. Through dendrogram we see that how many natural categories of a cluster exist in our big data sets. Like for example, just see here. First of all, in the x-axis we represent our clusters P1 till P6. In the y-axis we represent the distance between the clusters. Okay, so now just see, we merged P1, P2, P4 and P5 initially. Then what we did, we merged the P3 with P1 and P2. And what we did here is that we merged P6 with P4 and P5, and at last we merged all these points. Okay, so this part must be clear. Now just see, what we do is that we find the horizontal line which cuts the vertical line at the maximum points. And what we mean by vertical lines, the like just see here, this line 1 2 3 4, this cuts these vertical line, and the condition is that this line should not pass through any of these horizontal lines which I have bold or which I have make dark here. So you can see that 1 2 3 4. So my dendrogram is giving me a visual representation that my big data set can be naturally divided into four clusters. And here the clusters, one is different in nature from the cluster 2, and similarly for the other clusters. Like for example, if we have this as a student data and suppose n comes out to be 3, so we got to know that the average the students data can be classified into majorly three natures or three categories, that is weak, average and topper. That is that the dendrograph help us to give get a hidden instinct from our data, that what it is basically, that what it is representing, how many types of peoples I have. Like for example, if I suppose I have a shopping data set, so on the basis of the shopping data set I can have customer data set. For example, I have my budget customers which do shopping on the basis on for certain price. Second is the premium customers, premium that buys a costly item. Third is the seasonal customers which buys only sometimes. The fourth is the random customers which comes at any time and buys a particular product. So you must be clear. So through the dendrogram it helps us to give a visual representation that how my data set, big data set, is naturally divided into how many clusters. Okay, so you must be clear till here. Now let me tell you what the distances are measured on the basis of some common distance measuring techniques which you must know, that is Euclidean, Manhattan and the cosine. Okay, like here what we are measuring, like the distance of this from this cluster, or suppose I have initially only one point cluster, like here the distance between these two are measured through the formula of Euclidean or Manhattan or the cosine. Now just see, when we have only one points, like initially when we do our cluster, it is very easy that we know that we have to find the distance between these 2 points only, no doubt. But now suppose I made a cluster, like this is my cluster and this is my cluster. Now how will I measure my distance, what I will take? So for measuring this distances between cluster to cluster, we have basically four methods. The first one is the single linkage or our minimum distance. So what happens is that we find the distance of each point here from each of the points here, like I will measure this distance from it also, from this also, from this also and from this also. Similarly this point distance from this also, this also, this also and this also. Okay, and suppose there was another cluster also, this, so same thing will be done, this also, this also, this also, this also. Okay, so I will be getting some of the values of the distances, and suppose I get a minimum value m1 out of all the possible combinations, and I here get a value m2, which is the minimum distance from this cluster from all the possible values. Okay, now suppose m1 was less than m2, so what I will do, according to this I will merge these two clusters which are at a minimum distance. Okay, now let me tell you the other is nothing but the just opposite of that, that is the maximum distance, complete linkage, that is the maximum distance. I measured the distance of each point from each point of this cluster, and I measure the distance from each point on this cluster, and I get some maximum value mx1 mx2 for these two particular cluster. And if I suppose my mx2 was greater, because this was at the minimum, mx2 I was getting maximum, so what I will do, I will merge these two clusters if I decided my linkage will be done on the basis of the maximum distance. Third is nothing but the average. What happens is average, that we find the distance from each of the point, we calculate its average one, and then we find out the distances from all these points, and then we calculate the average 2, and the minimum average is to chosen to cluster. So this was my third method, that is the average. Now the fourth is a ward. Ward method is something different from these values. What happens is that in the ward method, I don't just calculate the distance of the points, but I want to know that if I make this a cluster, then will the variance inside the cluster or the sum of the errors will be low or will become high. Now suppose I have an example data set like 2, 3 and 10. Initially what will happen, this is also a cluster, this is also a cluster and this is also a cluster. Okay, now suppose I make cluster of c1 and c2, so what will happen, I will calculate the sum of the squared errors for this. Okay, this will become clustering these two values like 2 3, 2 plus 3 divided by 2. First of all we calculate our mean will be 2.5, and then we calculate our sum of the squared errors, that will be nothing but data minus its mean whole square plus data minus its mean point whole square. So we will be coming out with some random value y1 suppose. Okay, similarly I will calculate the same for 310 and 210 also. Okay, so I will get three values of sse, sse2, sse3. So suppose I get to know that on merging this c1 and c2 I am getting the minimum as sum squared error within the cluster. So what I will do, I will initially merging the 2 and 3, and 10 will be remaining here. So now at last what I will do, at last I will merge this. So we get to know that how we do the clustering, that is the basic linkage method here. So we have completed our process and what we do to find the linkage between the cluster. Now the advantage of this is that here we get a visual representation through the dendrogram, and it is more intuitive and simple method. And the second is that we do not have to initially count that how many clusters we have to make like we do in the k-means clustering. And but it has also some of the disadvantages, like it is not good for the large data set, it becomes slow process. And second is that it is affected by the noise or the outliers. So just see here what we have done till here to here. And if you, this is all which you need to know in this. Okay, so let us do a warm up. So what we learned, we learned about the agglomerative clustering. In the agglomerative clustering we learned that it is a bottom to top approach, that clusters are made, dendrogram is made. Dendrogram gave us a visual representation, it tells me on a large data set is basically the category of what, how many features, main features. And third is that we see how the clusters, when we make clusters, how we decide that what we have to cluster or we have what we have to not. This is decided by us. There are majorly four methods for this. So thank you.